Welcome to the next lesson. Today I would like to talk about one of the most important part of the design system, tokens. They serve as a single source of truth. Let's start with variables. So variables is actually a new Figma feature. It allows us to create design tokens and to do prototyping. But prototyping is something that we are not going to cover today, and it's actually nice to know, but the main focus is on tokens. Think of the design tokens like nicknames for your designed elements. Instead of using hard-coded values like hex code for color, for example, or some pixel sizes, we give them names. These names or tokens store design details in a simple, easy-to-read way. They work with all style files in your system and make your design consistent and easy to scale. So, for example, instead of using some hex code, I would just call it, for example, color primary or pink 500. We will discuss naming conventions later on, but you need to understand this. Token is a nickname for your value so that it can be easily understood for all of the team members. The idea of design tokens started with the Salesforce design system in 2014. The design tokens emerged as a solution to manage design-related information in a complex project more efficiently and at a scalable level. They're like the smallest but most important part of any design system. They're like the building blocks of any design language, making sure that your brand looks the same across all platforms, whether it's an Android, iOS, or if that's a web application or an app. In short, design tokens are the backbone of your design system. They keep your brand's visual style consistent and easy to manage. Let's start with token types first. Here's a graph, and at the very bottom we have raw values such as color values in hex or RGBA that can be absolute and relative length at size units. It can be percentage or numbers. These are not tokens. Above we can see global tokens. These are the primitive values in our design language, represented by context agnostic or generalized names. For example, with colors, global tokens refer to what they are. In Figma, variables use the name primitives. So these names can be pink, gray, red, green, and so on. All design foundations start with a global design token and a value. The single token is later inherited to alias tokens representing a specific context or abstraction in a design. So alias tokens relate to a specific context and communicate the intended purpose of a token. Alias tokens are practical when a single value appears in multiple places. In Figma variables, the common name for them is semantic. So instead of referring to colors by what they are, you can also refer to them by what they actually do. Next one, component specific. They are representation of every value associated with a component. They often inherit from alias tokens, but are named in a way that allows engineering teams to be as specific as possible in applying token in a component development. So it's quite useful for engineers but rarely used in the Figma design, for example. To understand it more, let's look at the example. This is a screen from Revolut app, and we can see if we use a picker that the same blue color is applied to the button, to the icon, to the chip selected state, to the text link, and to the text on the chip unselected state. And if we would like to give it a name, we would like to create another state of a value, and we would like to call it blue 500. So this way, instead of using some unfamiliar hex code, we're giving it a name so that it's easily understood by all people in the team. Then we can go another level and we can show the use case. So this blue 500 is used actually on a surface, for example. This is semantic level of tokens, and also as a text primary. So this is another semantic level, though they both refer to the same global token and store the same raw value. Then we can go even one level further and create a component-specific level of tokens. This way, we would have button surface primary, for example, and chip surface selected. So why would we do that? As you can see, we have 4 levels, and at each level, the token doing is something. At the first level, token is defining the name for the color. At the third level, it is defining the use case. And at the fourth level, it is defining the component and the use case together. We would do that so that if I would like to change the chip surface selected color by itself, I can only change this specific token, and therefore the surface primary will not be affected. The same way, if I want to change the color of all of these components, I can just change my global token. or I can change just the raw value of my global token, or I can change, and instead of to surface primary assigning blue 500, I can just assign another pink 500, and with this way we could have several themings, for example. Now let's talk about naming conventions. Usually teams spend a lot of time and brain power to find the perfect logic. You can find inspiration in other open design systems, but that doesn't mean it will work for you. I recommend a workshop to find the most optimal structure for your specific use case. But importantly, names should be short, meaningful, easy to understand, modular, and consistent. To make namings modular, we could use modifiers and the same structure for all of them. So here's the most common approach and practices for complex alias or component-specific tokens naming structure. I'd like to start with complex because after that we can just simplify this naming structure. The first, it's category. It answers on the question, what attribute are you referring to? That can be color, typography, shadows, spacing, border radius, and so on. The second is a property, or also called type or usage. It answers on the question, where is it being used? Text, background, icon, border, body, headings, and so on. You can be as specific as you need. The next one is an item or a component. It answers on the question, what component it is affecting. It can be input, button, segment and control, checkbox, tab, link, and so on. The next one is sub-item or variant, in case if there is any variants that can be primary, secondary, or it can refer to the site, for example, Excel or small, big, etc. And it depends on what kind of structure you chose for your variants. And all tokens may not have variants, and that is fine. And the last one can be state. That is the interactive state of a component, which can be active, disabled, inactive, hover, focus, and so on. So we can use those modifiers. And now let's consider color tokens naming based on their types and hierarchy level. First, let's start with the global naming. Some teams actually love names like sunshine yellow, fresh pink, bright blue, but this only works when you have a limited set of colors. It is memorable and easy understood by non-designers, but it's tough to memorize like many 20 plus crazy names. So global tokens store raw data, not intended for standalone usage. It's better to use them as a reference for alias or component specific tokens. Here it is good to use literal color naming like red or blue and a numerical scale, where 50, for example, is the lightest and 900 is the darkest. That's the approach I personally use. The next one is semantic tokens. They are our abstraction layer. They reflect the usage of a value in the UI instead of a literal value. Here, for naming, we can use usage modifier and intent modifier, like primary, secondary, danger, success, hero, accent, or variant modifier. If your project is small and you're going to have only a few themes, you can go ahead with global and semantic naming. The next one is the component-specific level. Here we can use such modifiers as component, usage, and the variant. And most of the time, such naming is used only for the development and not so much in Figma. So here's an example from Uber Design System, so-called base. They have first primitive tokens for the color. Here we have all the different tints and shades, and the thing is, most of this may not even be used, but they should be there in case if they would like to refer in the alias or component specific tokens. Then we have a foundation level. So this is basically the color palette so many people are used to, and those kind of things you can see on the internet or on Dribbble, or when you search create a color palette. These are just the main tints of the color. The next set is the core. Here we use background, content, and border, which is quite an abstract level, and these are semantic level tokens. They also used here inverse values, which is not actually the dark theme. For the dark theme, we have a separate tokens. So the button background could be background inverse primary, and the content could be content inverse primary. And they also have core extensions for some other use cases, and some extra values and tints. And here is an example of tokens from the Atlassian design system. So here we have a space tokens, and we define how we use it. For the space tokens, we use just a simple category modifier, which is space, and a numerical scale. For the opacity tokens, we used the category opacity and some usage example. And for the color, we use different levels, which is an abstract level and the component specific based on the case. Now let's consider something that tokens actually are very useful for, the theming. Here is, for example, two brands, A and B. Let's say we have defined all of our tokens. We defined component-specific, semantic, and global tokens. And we have created a design system and maybe a project for the whole brand A. So if we would like to change something, instead of changing the whole system and the structure, we can just change the raw values right here. So everything can stay the same, and by just changing the raw value and applying another global token, everything will stay the same, but the colors will change. Same can be applied to the typography, spacing. So this way we can change, for example, modern design, which use some Poppins font to more luxury and apply serif font for that. Let's specifically see how it works. Here, for example, we applied color surface primary, and we will go here into variables. And for example, instead of changing the color itself, I can just here refer to another token and make it just black. So you see, the component will stay the same. And I can even go back, apply this, and create another theme. I can call this brand B. And here I would just change to the black. And what I can do, this one is by default is set here in the layers to the mod 1, which can be called brand A for simplicity. And this one I will change to brand B. The same thing can be applied to the radius, the same can be applied to the sizes, to the paddings, to the typography, and so on. So this way, tokens actually allow us huge scalability, easy to maintain, easy to scale, flexible, and each is actually one source of truth. Let's talk about what is the difference between tokens and the styles. Tokens allows us nested referencing. This is something that I have just showed you. So here in the variables, instead of just defining the hex value, which is hard to maintain and hard to change and fix here and there, instead of that, I just refer to all of those global tokens that I have just created. I go to the semantic level, and here I just choose all of these colors. For example, we have the styles here. So you see here what happens with tokens. If I would like to change the value of the blue 500 to the pink one, it's going to affect all of my tokens. Here the surface parameter didn't change because I applied it to another token set. So I go back, I can even change it not primary, and here is actually the name of this token now is primary 500, and this can be also the global naming. Instead of using the specific name, I just give it a primary or a brand. In this way, it doesn't matter which color we use, it just defines the brand. While with styles, it doesn't work this way because it doesn't allow us nested referencing. If I would like to create a global token or a global style, it allows us to serve inside only a raw value. So if I would like to change the blue 500, I would have to change it manually everywhere. So let's say I have it here. I would like to change this 500. Let's say it's applied already somewhere. I've changed it to the pink and nothing happened here. Well, okay. Then let's say I would like to change the surface primary. Then I would have to go and also change it manually. And the same will happen to the text primary, border primary, and imagine how many of these semantic and component specific styles we would have. This is not very scalable. And the reason, like, you would say, why do we even need tokens in this case? Well, if I had like border, text, and surface, it's just one case when it has all of the blue color. But what if the component or the system itself changes and I need to change only the text link color to the black, for example, or a gray underline? Instead of changing the whole system and instead of changing the design on each UI page, I could have changed tokens. So if you imagine a big project with many, many screens on there, and this hard working, changing, this is very time consuming and tedious, and it doesn't really worth it. So that's why we should go to using tokens instead of the styles. Nowadays, styles allows us to create and apply different properties such as image, linear, and other variables for the styles, while token or a variable can hold only one value. So here the image right now has the linear field, the image, and the variable itself. So we can apply different values here, while the variable itself cannot hold several items. So why do we need design tokens? Firstly, to spend more time on problem solving instead of figuring out which component to use, which color to apply, or what font size to use. Because designers should dedicate their time to solving challenges and crafting user experiences. And the second point is that this approach significantly helps engineers in building faster. Engineers won't need to code everything from scratch every single time. Just as designers create a design system, engineers develop a corresponding system in their code base. The ultimate goal is to achieve design and code parity. Basically, create this single source of truth, which means that all the information is stored in one place and changes in design will be also represented in the code. Lastly, design tokens guarantee design consistency, whether you're working with a small team of 2 designers or a larger team of 50 or 200 or 2000. A solid design system supported by design tokens ensures uniformity across all of your apps and platforms and products, providing a cohesive user experiences. In essence, design tokens streamline design and development, collaboration, and minimize miscommunication.